Hi guys, we've got two videos for this unit, so let's get started with 6.1. We're going to look at the exponential and logarithm relationship. The first thing I want us to think about here is inverse operations, right? So the inverse of addition is subtraction, right? To undo addition, we subtract. To undo something being multiplied, we divide. To undo something being squared, we take the square root. To undo something being cubed, we take the cubed root. So everything in math has some sort of inverse. But how do we solve equations that look like these? 10 to the x equals 100? This is really saying 10 to what power is 100? Well, 10 squared is 100. So our x is equal to 2. What about this one here? 10 to what power equals 1? Well, 10 to what power is 1? Well, anything to the 0 power is 1, right? So x is 0. What about this? 10 to the what power gives us 1,000? Well, 10 cubed. Right? We can do these ones quickly in our head. 10 to what power is 10,000? Well, that's x equaling 4. 10 to the 4th is 10,000. 10 to what power is 1/10? Well, to make those flip, right, we have a negative exponent. X is negative 1. Not all problems are going to be easy like this. We need to learn something, a new inverse operation, that is called a logarithm. So the inverse operation of base b is the logarithm base b. So the log with that same base. So if we're talking about base 10, just like we were up here, right? We have a base 10 to an exponent of x. If we're doing this just in general, we have 10 to the x is equaling a. Well, how do I use the inverse to get that x all by itself? This right here in red. You take the log base 10 and you multiply it. And what you do to one side, you do to the other side. So in your notes, I'm going to have some markers for us. I want you to put a box. It's red for me, but it's going to be black for you. So I want you to put a box of the same color so you can see what's happening there. Once you take the log of both sides, that log base 10 takes care of that 10 that you have there. So then you're left with just x. And then in your calculator, I'll show you in some other examples, you take log base 10 of whatever that a is. Okay, so that's in general. So if we were to look at some examples, let's look at this 10 to the x equaling 1,000 again. But this time let's use the log. So we would do log base 10 of 10x. And then what we do to one side, we have to do to the other of 1,000. So over here, we know this log took care of that. We want just the x. Well, how do we find log base 10 of 1,000? Let's go to our calculators. Log is right here on the left-hand side. And then we're going to type in 1,000. And it's 3, just like we had before. We said it was 3 up above, but now we know a new inverse. Okay. Notice on our calculator, let me jump back to that real quick. You don't see that little 10 on the bottom. That's because it's always going to be like pre-programmed as 10. So it won't show up as a 10. So if you just have a log all by itself, it just means 10. Let's look at this one. 10x equaling 72. I don't know what power 10 has to be to get to 72. So I'm going to take the log of 10x. And what I do to one side, I've got to do to the other. I know that taking this log makes that 10 go away, so now we just have x. Log of 72. Go to your calculator, and we want to find out the log of 72. We get 1.86. So 10 to the 1.86 power is going to get us 72. Let's keep going. 10 to what power is equal to 1 over 10? Well, we know it's negative 1, but let's try it out. If we take the log 10x, what you do to one side, we got to do to the other. This log takes care of the 10. So we have x equaling the log of 1 over 10. Let's check it out. Log 1 divided by 10 is negative 1, just like we did before. Okay, let's jump down to this one. 10x equaling 90. 10 to the x, I should say, equaling 90. I don't know what power that 10 has to be raised to, so I'm going to take the log to get that x all by itself. What I do to one side, I do to the other. Okay, I'm going kind of fast through this video, so pause if you need to at any point or ask me a question at any point. Okay, log of 90, that's going to be our x, log 90. You're going to be using your graphing calculators quite a bit for this unit. 1.95. So x is equal to 1.95. So 10 to the 1.95 power will get us 90. Okay, let's jump over these. These ones get a little bit more complicated. Now we need to solve a little bit of an equation, right? We need to get that 10 to the power of x all by itself. So the first thing we're going to do, right now these two things are being multiplied, we're going to divide by 2. Goes away over here, we're left with 10 to the x equaling 6. So 10 to what power is 6? Well, I don't know. I'm going to take the log. I'm going to get that 10 out of there, so we're looking at just the exponent. Oops. Okay, so those go away. X equaling log 6. To our calculators, log of 6.78. 0.78. 10 to the 0.78 power gets us 6. All right, one more here. So we need to get that 10 to the 2x all by itself. Right now, things are being multiplied, right? So let's get that 5 out of there. So we have 10 to the 2x equaling 5 divided by 25. Well, that's 5. And then we're trying to get the x all by itself, but that 2 is attached to it. So let's take care of that 10 first. That's our first layer. So let's take the log of both sides. And again, remember it can be log base 10 or it can be just log. I've been writing it both ways for these notes. I am okay with either way. So log base 10 with that base 10 cancels, so we're left with 2x over here. And then we have log base 10 of 5. Log base 10 of 5. So to your calculator, the log of 5 is this really long decimal. I'm not even going to write it. I'm just going to leave it. But I know that that long decimal, so it's 2x equaling 0 point long decimal, right? I need to divide by 2. So x will be equal to this long decimal here that I already have in my calculator. Oops, there it is. Divide it by 2. And we're going to get 0.34. Let's just do 0.35. 0.35. Okay, so 10 to the, let's see, 10 to the 2x equaling 5. So 10 to the 2 times 0.35, right, because x is 0.35, it's going to be equal to 5. Now let's look at this problem over here. We have 7x equaling 4. Our base isn't 10 anymore, but that's okay because the inverse that we learned, it's the log base whatever. In these cases, we were doing log base 10 because the base we had was 10. Now our base is 7. So guess what we're going to do? I'm going to even change colors for it. We're going to do log base 7 of this 7 to the x. And then what you do to one side, you have to do to the other. So now it's log base 7 of the 4. Okay, this log base 7 with this base 7 makes them go away. Now I just have an x log base 7 of 4. In your calculator, you're going to go to Math, and we're going to scroll down until we see log base. Okay, it looks like this. We're looking for base 7, so that goes down here. And then the number we're talking about is 4. So you're going to type it in just like you see it in your notes. And we're going to get 0.71. So 7 to the 0.71 power is equal to 4. All right, now let's look at the relationship between exponential stuff and logarithms. If we look here, exponential 2 to the 4th is 16. Well, if we take that base 2 and we say log base 2 of 16 is equal to 4. So both of these equations are describing the same relationship between the numbers 2, 4, and 16. 2 is your base, so I want you to get markers again and put a box around these things, right? It's colorful in mine, but it's not in yours. So the 2's are your base. Put a box that's the same color around them, right? We can do a box like this and a box like this. And then we have 4 as the exponent. 4 is the exponent over here. 4 is isolated over here. The difference in exponential form, your exponential form isolates the power. That's your 16. Your logarithm form isolates your exponent. So your power is 16, 2 to the 4th is 16, that's your power. The logarithm form isolates your exponent, which is your 4. I should put a box around this too. Here we go. So make sure you grab some markers and you fill this out. So in general, if we weren't to use numbers at all, we would do b to the c equaling a, which is the same thing as saying log base b of a is equal to c. Okay, I think the numbers will make a little bit more sense to you, but there it is in general if you want it to. And then here's a couple more examples with numbers. We are going to practice them in our notes right now. So we need to write the following in logarithmic form. So remember, the log form isolates your exponent. So we're going to say the log, I always start with that. What's our base? Our base is 3. Okay. Of our power, which is 81, is equal to our exponent. Our exponent is isolated with the log, so it goes on the end. Okay, let's do another one. The log of base 11. What color did I do last time? Let's see. Green. The log of base 11 times our power, 121, is your exponent, isolated on the side. Okay, let's do one more. The log, what's our base? 6. What's our power? This really long thing, 7,776, is equal to our exponent. Our exponent is 5. Okay, that's how we do those ones. The same pattern every single time. Now let's write an exponential form. Exponential form isolates your power. So, the way we start exponential form, when we read this as log base 2 of 128 is equal to 7. Our base is 2, log base 2, right? So 2 to the, here, let's underline it. Remember, your logarithm form isolates your exponent, so 2 to the 7th is equal to your power, which is 128. Let's do it again. Log base 4, that's our base, of 1024 is equal to our exponent. Our exponent is 5. Our power now is this, 1024. And you can check your work with this too. Like if you type 4 to the 5th in your calculator, you're going to get 1024. Okay, so if you're unsure if you're doing it right, check your work in your calculator and you'll see. Okay, log base 7, our base is 7, to what exponent? 3, because that gets isolated in our logarithm form. 7 to the 3rd is equal to our power of 343. Okay, that is it for notes today. Please let me know if you've got any questions. And we've got one more video to go.